And there's one more piece of terminology that I wanted to find that I forgot to back when we were talking about increasing and decreasing excuse me, sequences. It has to do with the idea of monotonicity of a sequence, but look, we're just going to call it a monotonic sequence. And this is just a fancy word for an increasing or decreasing sequence. Okay, so a monotonic sequence just implies that the sequence is either increasing or decreasing. Okay, it's just a fancy mathematical word. Monotonic, if you think about it, it means it behaves in one way, really is what it means, or decreasing, but not both. Okay, now there's a theorem that comes out of this, because once we have the idea of a bounded sequence and this idea of monotonicity or a monotonic sequence, think about this. Think about, I'm going to start this theorem and let's see if you can fill it in. Every bounded monotonic sequence does what? Every bounded monotonic sequence does what? Well, let's think about this. All right, let's say that we are bounded above and below. So I'm bounded above by big M, and I'm bounded below by little m, and I'm monotonic, which means what? I'm decreasing or I'm increasing, right? And I'm never changing that. I can't go up and then down. In other words, I'm either going to increase always or I'm going to decrease always. Well, what's got to happen? Well, I'm either going to do this. Notice I'm always decreasing. We get this asymptotic behavior here, don't we? I'm always decreasing towards my greatest lower bound, assuming this is my greatest lower bound, or I'm always increasing towards my least upper bound. That's the smallest of all of the upper bounds, which means what? Every bounded monotonic sequence must do what? Must converge. Now you may ask, Ripley, wait, what is it? Why does it have to be bounded on both sides, from both above and below? Well, that's easy to answer. If I've got, here's little m down here, and this is a monotonic sequence. Now, you guys, I'm taking great liberties here, and that's probably incorrect that I should do so. What I should be thinking of, not of these as continuous curves, but as, remember, individual points. So this guy would be A1, and this would be A2, and A3, etc. Right? I'm just so used to thinking of them as thinking of sequences as taking points from functions. But there is something a little crazy that we got to be careful with. If you think about it, a function could be doing all kinds of crazy things between A1 and A2, all kinds of crazy things between A3 or A2 and A3, all kinds of crazy things between A2, where am I? A3 and A4. And because we're just taking the points at which this thing is increasing, that doesn't mean that just because the sequence is increasing, that the function itself is necessarily always increasing. There could be some weird stuff. Typically, with what we're going to deal with, that's going to be the case. All right, so let's go back to this guy. Notice this. I am bounded below by little m, right? I am also monotonic. I'm increasing. But I do not converge, because this guy takes off for infinity. Right? So if I'm going to make sure that I converge, then I need to have a sequence that is bounded both above and below, which implies boundedness and monotonic. All right, that's it. That's the last of the theorems. I know this was a long section. These sections in Chapter 8 are pretty long, so I apologize in advance for some time that you're going to have to spend with these guys. And they're also note-rich, so make sure that you're taking good notes. And, you know, put me on 1.5 speed so I sound like a chipmunk. Christmas. Get out of here. Have a good day. I'll talk to you tomorrow.